Mathematics is generally defined as the study of abstract things such as counting, groups, and relationships. This definition is sufficient for most purposes, but it is actually a conflation of how we describe things and what in particular we are describing. So how are we choosing to define mathematics here? The structure, syntax, language, and symbols we use to describe these concepts, or the concepts themselves? Counting, groups, and relationships are clearly our attempts to describe the world. If these abstractions make for really good predictions of nature, then are we simply pulling back the covers on nature's mechanics? Consider topics which are developed with no use in mind, only to be applied to a physical phenomenon decades later, like topology and its usage in cosmology. But how would we respond to someone who claimed you could, in theory, formulate an idea or equation which has no basis in nature, but is logically valid? But is this actually possible? It doesn't seem likely. The validity of a logical statement is based on requisite knowledge. Let's look at this statement. If a Toyota Corolla drives 100 miles per hour, it will take flight. We know this statement to be false because we know a lot of information about cars, and we know a lot of information about flying, and in the vocabulary of formal logic, we would say, the conclusion does not follow from the premise. One could take it a step further and criticize the very foundation of mathematical study, formal logic itself. This is a valid point and is addressed interestingly by Gödel's incompleteness theorem, which says everything we know is based on unprovable axioms. Even still, formal logic, and the mathematics built upon it, has served us very well in our observations and predictions about the natural world. Certainly, if Earth ceases to exist in an instant, sports cars, elephants, and the particular method in which humans describe and predict the natural world will also cease to exist. Of course, the way electrons interact with each other and the relationship between a gas's pressure and temperature will be preserved. Consider another thought experiment. Imagine humans lose every scientific document and also their scientific memories instantaneously. We would have to start from the beginning with the most basic scientific experiments and observations, perhaps with falling objects. There is no reason to believe the kinematic equations of classical mechanics will no longer reasonably describe falling objects and baseballs thrown at an angle. Isomorphisms will still exist between particular groups, even if we do not call them isomorphisms or groups. We will not use the same words and symbols to represent things, but we will still represent them regardless, and any particular representation is inconsequential so long as it is consistent and is based on a kind of formal logic, whatever form that may take. The Navier-Stokes equations are among what's called partial differential equations, and they describe the motion and flow of viscous fluids. They're very complicated, but anyone with a thorough math background can look at the equations, which are comprised of symbols only, and understand what they say. If one were a masochist, one could represent the equations in terms of words only. It would be a lot of words, but with enough detail, the words would say exactly the same thing as the contrived symbols in the equations. In short, the natural phenomenon we attempt to describe and predict exists independently of us, as do the relationships between them. So it does not seem productive to define mathematics as the structure with which we describe the world, as this structure is arbitrary as an abstraction of abstract things, and is therefore completely contrived and invented as we go. As an aside, one might say the way in which we represent concepts has an effect on understanding of the concepts themselves, as our structures of explanation are products of the human mind and our perceptions. Even if this is the case, our structures of explanation still predict the natural world accurately, even if only from the human conscious perspective. Even if that is the case, there is no problem, as we only have one way to interact with the world, and that is through our conscious experiences. Our potentially limited or skewed perception of the natural world has little bearing on how we choose to represent it, or how it actually exists. So if we are to say mathematics consists of concepts, namely things, their quantity, and relationships, then it exists outside of the human mind. If people didn't exist, gravity would still be reliably ruining apples. Various abstract math topics have showed us that no matter what language and form we use to describe things, we more often than not still end up at the same place. For these reasons, it seems more accurate, and perhaps more romantic, to say math is discovered.